Here we go. We appreciate everyone being available to attend this webinar. I think under this new norm, it's going to be something that the company on a global scale will be trying to push a little bit more frequently. Unfortunately, there's no way we can do this on a face-to-face as we normally did, William and I. And so basically, we're going to be talking about the 2020 hurricane outlook for the Atlantic season, for the hurricane season. And this is something that we've been doing as a company since 2014. And it became some sort of a trademark of MatthewsDaniel throughout the market as and when the hurricane season begins. William gets his numbers and presents his predictions and findings on behalf of MatthewsDaniel. So the panel is going to be composed by me and William, myself being with MatthewsDaniel for 13 years, and since 2018 I set up the office in Brazil in 2007, and since 2018 I have relocated to Houston, and I am responsible for the claims division in all of the Americas. And while William is our global head of weather and forensics for MatthewsDaniel. Those of you who are not familiar with MatthewsDaniel, we have been around for almost 60 years, and we are specialized in complex claims and marine survey solutions on a global scale, more to the oil and gas industry, both downstream, upstream, and obviously midstream. So without further ado, I pass the floor to William. I would just respectfully ask that everyone who is attending the webinar do keep your mics in mute, and so we can avoid some echoing, and we'll be happy to take questions at the end. William, the floor is yours.
Thank you, Manuel. I'm going to start with this picture here. These are the major hurricanes that came in the Gulf of Mexico since 2000 for last 20 years. And the reason I focus on Gulf of Mexico first is because the two hottest spots for the major hurricane landfall potentially is from Mobile, Alabama to New Orleans area here. And the second hottest spot is from Houston, Galveston area to Lafayette, Louisiana area. And you can see Hurricane Ike happened in 2008 in this area, and also Hurricane Rita in 2005. And of course, everybody knows the Hurricane Katrina in 2005, the most destructive hurricane in the New Orleans area. Among these hurricanes, Hurricane Ivan is probably the most memorable to me because Hurricane Ivan caused about 90 feet of wave, which is about 28 meters, and disturbed a lot of the soil in the Mississippi Delta area and made a lot of the fixed platforms and jackups slide down along with the mudslide. Personally, Ivan is also memorable to me because this is when my career started. I wanted to become an actuary in the beginning at an insurance company. So I went in for an interview, and the hiring manager said, "Hey, William, we really like you, but we have somebody else for the actuarial position. But instead, would you be interested in modeling?" And I told him that I was very interested in modeling because I'm 6'1" and I go work out twice a week. But of course, he meant numerical modeling. So I became a CAM modeler in 2004, and 2005 we had another set of very strong major hurricanes blow through in the Gulf of Mexico. And you can see once again Hurricane Rita here, and then Katrina. And also I learned that some hurricanes can go sideways, and Hurricane Wilma went from the Yucatan Peninsula, making second landfall in southern Florida. Before we go too far, I want to summarize the 2019 Atlantic hurricane season. Last year, we forecasted 6 hurricanes would occur, and we had 6 hurricanes. Out of these 6, we had 2 major hurricanes, Hurricane Dorian and Hurricane Lorenzo. We're not going to talk about Hurricane Lorenzo today because it didn't make a landfall, but we'll focus on the major Hurricane Dorian. Major Hurricane Dorian peaked as a Category 5 hurricane with a sustained wind speed of 185 miles per hour, and its gusts reached about 220 miles per hour. It was the strongest hurricane landfall in the Bahamas in the history, and it was the strongest hurricane in the Atlantic Ocean, followed by Hurricane Allen in 1980. Here is the path that the major hurricane Dorian took, and you can see the hurricane making a landfall in the Abaco Islands as a Category 5 hurricane first, and then making another landfall in the Grand Bahama as a Category 4 hurricane. Every dot along the path is 6 hourly, every 6 hours. And you can see the Bahamas area, the dots are closer, which means the hurricane hovered over the Bahamas for some time. The most destruction we saw were the yachts, and it was keeping our adjusters on their toes. While all this destruction was going on in the Bahamas, I was in Florida enjoying the sun, and my manager called and he said, "Hey William, you need to go over to Abaco Islands and help out." And I said, "Well, I cannot go there." And he said, "Don't be lazy." But I really couldn't go there because the Leonard Thompson International Airport in the Abaco Islands was on the water. Here's the before Hurricane Dorian passed through, and here is the after. And also the mud, which is the immigrant neighborhood in the Abaco Island, mostly was on the water, and the Hope Town nearby the Marsh Harbor really had little hope left after Hurricane Dorian passed through. After the Bahamas, Hurricane Dorian continued its path towards North Carolina and made a final landfall in Cape Hatteras. Last year, we shared the fake news in the media about the wind speed. This year, we want to share the fake news about the flood levels. Here is the live reporter reporting the flood level along the North Carolina coastline, like the Bahamas. And all of a sudden, you see this man walking across the flood area with a stick on his shoulder. It was a historic moment because the local news channel captured the holy man. Now let's move on to talk about some of the conditions that are favorable for hurricane formation and intensification. Sea surface temperature is probably the most important information for hurricane formation. And here's the map of the sea surface temperature for this week. And every time we look at the sea surface temperature, we focus on the 26 Celsius or greater areas, which is below this blue line. And you can see the Caribbean Ocean is quite warm. Actually, this area right now is warmer than the long-term 30-year average, but you're not hearing any news in the media stating that there is a tropical storm formation and intensification into a hurricane in the Caribbean Sea, and that's because we have too much aerosol blowing from the West Africa. When we have so much dust aerosols in the atmosphere blowing through the Caribbean Sea all the way to Houston, Texas in the yellow circle, this dust aerosol suppresses the rising air from the sea surface, and without the evaporated air into the atmosphere, creating instability, it is very hard for tropical storms to form and intensify. In fact, last week was the record high dust aerosol level since 2003, almost for 15-16 years. Here's the media coverage in San Juan, Puerto Rico. You can see the atmosphere is filled with the dust. And even in Houston, Texas, it was getting pretty cloudy looking, and the media was saying we should wear a mask. But of course, we are wearing masks already because the COVID-19. Another reason why sometimes we don't have a tropical storm or hurricane in the Atlantic Ocean is because the vertical wind shear level is too high. So let me explain what wind shear means. Wind shear is change of wind direction or wind speed with altitude. So for example, let's say this gray block is the hurricane or tropical storm cloud column, and in a weak shear environment, the lower wind and upper wind blows in a similar direction or at a similar speed, so the air can circulate properly from the center of a hurricane towards the outer band of the hurricane cloud column. However, in a strong wind shear environment, the lower winds and upper winds blow at different directions at different speeds, so that the hurricane cloud column leans over, and eventually without the proper circulation of air, it can weaken, or if the top portion of the cloud column is broken away from the bottom portion, then hurricane can disappear. So I want to share a real life example of strong wind shear environment. In this satellite image, you can see the blue and green, which represent the upper clouds, and you can see some more here at the bottom. The lower clouds have no color. You can see some here. In the animation soon, you will see the lower clouds moving this direction, whereas the upper clouds are moving more in this direction. So here's the animation. You can see the upper portion of the cloud column in blue and green is getting washed away from the bottom portion of the cloud column because the wind in the upper atmosphere is stronger than the lower atmosphere. And this is the definition of wind shear. For this tropical system, the wind shear was too strong, so it weakened significantly before it got to the North Carolina coastline. So at the moment, we are experiencing strong wind shear environment in the North Atlantic, but this condition will change in July and August. And we know that because we're going to go from El Nino condition to La Nina condition. So let me explain what constitutes El Nino and La Nina conditions. We look at this area called the Nino 3.4 area in the yellow box around the equator. And when this area becomes 0.5 degrees or warmer, it becomes the El Nino condition. And during El Nino condition, we experience stronger wind shear in the Atlantic Ocean, which means less hurricane formation and intensification in the Atlantic Ocean. Conversely, when this area, Nino 3.4 area, becomes 0.5 degrees or colder, it becomes La Nina condition. And during La Nina condition time, we have weakened wind shear in the Atlantic Ocean. So we are more likely to have a hurricane formation and intensification in the Atlantic Ocean. So at the moment, we are in the weak El Nino condition, but we are transitioning to a weak La Nina condition. And we know that because we have models. So let me share the model outputs. So once again, 0 is the long-term 30-year average sea surface temperature in the Nino 3.4 area in the Pacific Ocean. And when this area becomes 0.5 degrees or warmer, it becomes El Nino condition with a stronger wind shear. When this area becomes 0.5 degrees or colder, it becomes La Nina condition with a weaker wind shear. Anywhere between, we call it neutral condition, and it's just normal wind shear levels. Back in March, the sea surface temperature in the Nino 3.4 area was about 0.6 degrees warmer than the long-term 30-year average, which makes it the weak El Nino condition. And with that observation data, various modeling agencies, they use their own models to calculate whether we're going to stay in the El Nino area or convert into the neutral or La Nina area. So I put the average of the statistical models in the green line and the average of the dynamical models in the red line. Statistical models are used by the academic institutions more. For example, the famous ones are the Florida State University, UCLA is one, and also the Colorado State University. Whereas the dynamical models, more of the governmental agencies using more. So NCEP is famous, NOAA's NCEP. JMA is the Japanese meteorological agency. And the other famous one is the UK Met Office. It's quite famous. And then you can see like NASA and European Center for Medium Range Weather Forecasting. I mean, they are also famous. Blue line is the CPC, which is the Climate Prediction Center estimates. And during August, September, October time, ASO, NOAA is predicting that we are going to go into a weak La Nina condition. But MatthewsDaniel meteorology team think we are going to stay in the neutral area. So there's a little difference, and I'll show you what that means in terms of the number of hurricanes and major hurricanes for the season. Now we're going to fast forward to the future. So this is the sea surface temperature forecast map for July, August, and September. First thing to notice is the Nino 3.4 area is showing signs of white and light blue, which means it's going to be average around 0 or possibly into a weak La Nina condition. During this neutral and weak La Nina condition, we have weakened wind shear, so we are more likely to have a tropical storm formation and possibly intensification in the North Atlantic Ocean. In July, hurricanes and tropical storms can form in this dotted area, and when a system forms, it can go in 3 directions. It can go towards the North Carolina coastline, or into the Gulf of Mexico, or towards Yucatan Peninsula. In August and September time, Hurricanes and tropical storms are more likely to form in this main development region. And when a hurricane forms here, they have three directions to go: into the North Atlantic Ocean, or towards the eastern seaboard, or to the Caribbean Sea and possibly Gulf of Mexico. So now let me digress and explain why sometimes hurricanes go into the North Atlantic and sometimes it comes into the Gulf of Mexico. There is a large pressure area called Bermuda High hovering over Bermuda. That's where the name comes from. It's actually quite simple. When we have a hurricane or tropical storm formation, they have tendency to go into the North Atlantic Ocean, but hurricane itself is a low pressure system, so it cannot go into the high pressure area. So the trade wind from the West Africa blows towards the Caribbean and moves the hurricane along the bottom of the high pressure area. Sometimes the high pressure moves sideways towards the Europe, and when this happens, the hurricanes take this opportunity to hawk the high pressure area towards the North Atlantic. But sometimes the high pressure area moves towards the Caribbean, then the hurricane cannot move into the high pressure area into North Atlantic, so it's left with a choice to go into the Caribbean Sea and possibly into the Gulf of Mexico. So now let's talk about what weak La Nina means in terms of the number of hurricanes and major hurricanes for the season. On a 30-year average, we normally have 12.1 tropical storms, out of which 6.4 become hurricanes and 2.7 become major hurricanes. Major hurricanes are the category 3, 4, 5 hurricanes, and this is based on the Saffir-Simpson scale. Let me show you the CAT scale that we have. Here are the CATs. CAT 3 starts at 111 miles per hour, and CAT 5, anything that has a sustained wind speed of 157 miles per hour. For this year, NOAA estimates that we should have 13 to 19 tropical storms, out of which 6 to 10 will become hurricanes, and 3 to 6 are likely to become major hurricanes. For MatthewsDaniel's prediction this year, we estimate 17 tropical storms, out of which 7 hurricanes and 3 major hurricanes could occur. Out of 7, we estimate 3 hurricane landfalls are possible in the continental US. In terms of the probabilities, 45% chance that hurricane landfall is possible in Florida or eastern seaboard, and another 40% probability of a hurricane landfall in the Gulf Coast states, Texas, Louisiana, Mississippi, and Alabama. In terms of the major hurricane landfalls, there is 70% chance that at least one major hurricane will make landfall in the continental US. This is very good information and takes a lot of effort to come to this point, but of course my manager wants me to share exactly what area is most vulnerable to hurricane and major hurricane landfalls this year. So we decided to divide the Gulf of Mexico region into 3 areas. So area 1, if a tropical storm comes towards area 1, it has a 42% chance that it'll become a hurricane, and there's a 19% chance it'll become a major hurricane landfall in the area 1. For the area 2, if a tropical storm comes towards this area, it has 44% chance of becoming a hurricane landfall, or it has 24% chance that it'll become a major hurricane landfall. For area 3, there is a 45% chance it'll become a major hurricane into this area, and there is a 29% chance the system will become a hurricane landfall in area 3. And of course, my manager not happy with this information. He wants me to provide more value to the clients. He wants me to drill down into exactly where it'll be a hurricane and major hurricane landfall this year. So we decided to create smaller boxes within the areas. So area 1, this yellow dotted line area is most likely to experience a tropical storm. And if tropical storm decides to become hurricane, it has a 42% chance of becoming a hurricane this year. Area 2, the yellow box area, no, sorry, orange box area is most vulnerable to hurricane and potentially major hurricane. And if a tropical storm becomes a major hurricane and goes there, most likely it's going to go towards Houston and Galveston area this year. In Area 3, the most vulnerable area is between New Orleans and Mobile, Alabama. And Category 2 to Category 4 hurricanes are possible this year. Hopefully not a major hurricane into a New Orleans area this year. And my manager also wants to know if Bahamas will experience another major hurricane this year. So we did a study around this box area. And within this box area, if a tropical storm comes, then it has a 43% chance it'll turn into a hurricane and 26% chance it'll be a major hurricane. Within this area, including the Bahamas and the southern Florida, the most vulnerable area for hurricane and major hurricane this year is the southern tip of Florida towards the Florida Keys area. And it has some chance of hurricane and potentially major hurricane. If predictions are right, then most likely scenario is there is going to be some system coming into southern Florida and skirting or making landfall in Florida Keys, and it can potentially go towards the New Orleans or potentially come towards the Houston area. The only good news this year is in the Caribbean islands. Puerto Rico and Virgin Islands experienced heavy damage from Hurricane Maria going through in 2017. But for this year, most likely, we think it's going to be tropical system going through this area and low chance of hurricane or major hurricane impacting this region. My manager also wants me to tell you which one of these hurricane names will become major hurricane landfall this year. So we know it's not possible to be Arthur, Bertha, and Cristobal because they already happened. And if you ask me to put money on any of these names, I'll put my chips on Hurricane Hannah and Hurricane Laura. And this is just guesstimate and it is not accurate in any way. So please do not use this information for gambling, for example. Next, I want to tell you how to use the cone of uncertainty. So say we have a tropical system coming into the Gulf of Mexico, and normally NOAA puts a cone of uncertainty similar to this one here. This one I just drew in as an example. And most people will say, hey, William, these assets here outside of cone of uncertainty will be safe. And this is not true. The hurricanes not go in the center of the cone of uncertainty normally. Cone of uncertainty tells you where the eye of the hurricane will go. So for example, hurricane can go like this here, or even like this one here. So in this case, the east quadrant of the hurricane is the worst wind and worst wave. So the assets in the orange eclipse will be exposed to hurricane. So these are not safe. The next question is, how about these assets in this area away from the cone of uncertainty? For Gulf of Mexico area, this area is not safe from hurricane. So hurricane can be like this here from the tropical storm area here. And this is because cone of uncertainty is only accurate 2 out of 3 times. So it's 1 out of 3 times wrong. And that's 33%. That's quite large. And usually when the meteorologists get the cone of uncertainty wrong, they have to wear the cone of shame. And another reason that hurricane can blow up from tropical system like this into a major hurricane in the Gulf of Mexico is because we have something called eddy in the Gulf of Mexico. So let me tell you a little bit about the eddy loop. So here is the cartoon representation of the eddy current and eddy loop. So the eddy current pushes the warm water from the Caribbean Ocean into the Gulf of Mexico here, and then exits out below the Florida to the eastern seaboard into the Atlantic Ocean. And when this eddy current becomes elongated here, sometimes it gets detached and creates eddy loop. And this eddy loop travels to the west Gulf of Mexico and cools down and dies there. And this area is actually called eddy graveyard. And the problem with the eddy loop is when hurricanes go over the eddy loop area, it has very warm sea surface temperature down to about 100 meters, 120 meters into the seabed, towards the seabed. So that can be a large fuel source for hurricane or tropical storm to blow up to a major hurricane before it makes landfall anywhere in the Florida Panhandle to Houston, Texas. So let me give you some real examples of this. On October 7, 2018, Tropical Storm Michael was located nearby Yucatan Peninsula, and a lot of people thought it was just going to make landfall on the Yucatan Peninsula, but some of us thought it was going to go into the Gulf of Mexico, and it did. The thing to remember on this slide is it was on October 7, but within 3 days, Tropical Storm Michael could become a major hurricane and make landfall in along the Florida Panhandle. And this was possible because of the warm eddy loop. So here's the location of the tropical storm Michael initially, and then the times are shown in the numbers, 72 hours and 96 hours. And along its path, it encountered warm eddy loop here, and that provided enough fuel to tropical system and became a hurricane into a major hurricane before it made a landfall. Let me share one more example. Here's a Hurricane Harvey scenario. Back on August 24, 2017, it was not even a tropical storm, it was a tropical depression Harvey. And you can see the location of the Harvey here and the tip of Texas coastline and the Mexico. And this distance is normally not long enough and gives enough time for any system to become a major hurricane, but Harvey managed to do that. August 24th was when this image was taken alongside the satellite image, and within 2 days, it could become a major hurricane landfall at Rockport, Texas. And this was possible because of the old eddy loop. So here's the path of the Hurricane Harvey making a landfall, and here's the eddy loop that's formed out of the eddy current. And this is not the one that's responsible. It's the old eddy that traveled earlier towards the west Gulf of Mexico and became the source for hurricanes to feed the moisture and heat from the sea surface to become a major hurricane. Hurricane Harvey is going to be remembered for a long time as a rain event in the greater Houston area. Here's the footprint of Hurricane Harvey. You can see the track of Hurricane Harvey in and out along the Texas coastline and then traveled all the way to the northwest. And when you sum up all the rain from the Hurricane Harvey, it's going to be enough amount to fill the Niagara Falls for 7 days. Now I want to share the before-after pictures of the Hurricane Harvey flooding in Houston, but I don't want to cause PTSD for people who live in Houston and went through the experience, so please look at these pictures at your discretion. Here's Friday, it started raining, and Saturday, it started to flood in some parts of Houston, and here's Sunday. Here's another example. Highway I-10 from Houston to Lake Charles, Louisiana. Here's before Hurricane Harvey, and here's after Hurricane Harvey. So Hurricane Harvey flooded most of the highways in the greater Houston area, which means no work the next day. So when the rain stopped, people started to go to McDonald's for breakfast in canoes. And after breakfast, people start to tube down the receding water and relax, and some people took the dog out for waterboarding. And even President Trump joined the fun in sliding down in a garbage bin. And my manager asked, "Hey William, is this due to global warming?" And I thought this was a trick question to figure out if I'm a Democrat or Republican. But of course I cannot just ignore my manager's question. So I wanted to tell him that global warming is real. So I shared this proof with him. Now I want to share where you can find detailed information about active tropical storms and hurricanes in the Atlantic Ocean. If you are not receiving our advisories, simply send me an email and I can add you to our distribution list. And this is all free for our clients. Our report normally starts with corner of uncertainty, and I mentioned how to read the corner of uncertainty. The hurricane eye can be anywhere inside of the corner of uncertainty. It's very important. And then we move on to maximum sustained wind and gust information for the next 5 days. And not only that, we also include the significant wave and maximum wave heights in the report. So our marine and offshore clients can prepare accordingly. We also include model outputs. The numbers indicate how many hours from the initial position where the system is and which direction the system will go according to various model setups. We also include model outputs for intensity development. So model starts at 0 hour into the future, and when these lines cross the Cat 1 area, then it means it's going to develop to a Category 1 hurricane. But fortunately, most of the lines are shown in the gray box, which is the tropical storm intensity. So the models are forecasting that Cristobal will remain as a tropical storm until it makes a landfall. We also talked about wind shear. So here's the wind shear map for Cristobal. And here is the Gulf of Mexico area. Location of the Cristobal is here at the time. And it was going to, or it was projected to go towards the Louisiana area here. And along the way, it has a lot of wind shear to encounter. So we already knew that Cristobal was not going to become a major hurricane before it makes a landfall. So it was not a big concern for us. We talked about dry air briefly in the beginning of the presentation, and the dry air for Cristobal was this mass here, and the location of the Cristobal was like here. And tropical storms, they don't like dry air at all because they are a wet system, and when they mix with or encounter dry air or dry areas, then it can severely weaken the tropical system. On the last page of the advisory, we normally include the wind speed observation information. This information is taken from NOAA's aircraft going through tropical storms and going over hurricanes. And you can see the center of the system here, and each wind barb has information. So for example, this one says 35 knots of wind. Each barb is 10 knots, and half a barb is 5 knots. So if you add them, it's 35 knots. This is in knots, not miles per hour. This information can be quite useful, especially if a system goes over our client's assets and you have to show somehow what kind of wind speed caused what kind of damage, and this can be quite useful. Another tool that I want to mention is our Storm Tracker app. It used to be just Storm Tracker, but it's upgraded to Storm Tracker 2.0. And we wanted to be clever and come up with a new name. We wanted something to do with a storm, and our company name is MatthewsDaniel. So we thought maybe we'll do Stormy Daniel, but of course, that was already taken. So we couldn't do that. So we ended up just stating 2.0. Inside the app, we have light feed from NOAA indicating which area of the Atlantic Ocean is favorable for tropical storm formation. And once the tropical storm forms, you can check out the satellite map. It's real-time feed from various sources. And then once the hurricane comes in the Gulf of Mexico, it has a chance to go over some of the Gulf of Mexico assets. And based on the location of the assets and the intensity of the hurricane, we display which ones are likely to be damaged and potentially damaged. And the damage parameter for us is set by the wave heights and wave periods. So to summarize, here are the 2020 Atlantic hurricane season outlook. We estimate 17 tropical storms this year. Out of 17, 7 are likely to be hurricanes and 3 major hurricanes. Out of 7 hurricanes, we expect 3 hurricane landfalls and at least 1 major hurricane landfall in the continental US. I also want to share the bonus information for staying till the end. I want to share the hurricane forecast for next year, year 2021. We estimate at this time 20 tropical storms for next year, out of which 11 are likely to be hurricanes and 5 major hurricanes. Out of 11, 5 are expected to make landfalls in the continental US and 2 to 3 major hurricane landfalls. Normally, we don't share the forecast for the following year, next year, because doing the hurricane season outlook for the current year is already hard enough. But we've been seeing 2021 possibly having deeper La Nina and some other factors. So we think it's going to be even busier season next year. So for the clients who have opportunities to be prepared for our busier season, we want them to have the most possible time in advance. That's all the material I prepared for the presentation today. If you have any questions, I can take some questions now. And I want to mention, if you are seeing this in recording, feel free to shoot me and Manuel questions you have, and then we'll reply back to you. Or if you prefer just calling us, just call us. That's much easier, and then we can just have a discussion on any questions that you have about hurricanes or any other perils like hail, lightning, flooding. I mean, we do all kinds of weather, so let us know, and then we'll help you as much as possible. Now I hand it over to Manuel.
Thanks everyone for attending. I hope this wasn't as informative as you expected. Again, we apologize for the technical issues, but I think William was able to get the message across quite clearly. And again, if you have any questions about what the data that has been presented, please do reach out to him or to me if you wish to, and I can redirect any questions directly to William. And I hope you guys stay safe, and we as we sail through these tough times, and hopefully we can all get together on a more less restricted environment sometime soon.